Hello, and I want to welcome you back to 5.3. We're going to look at problem set 5. Multiply the following fractions. Okay, so what you want to do first is use the multiplication and division of fractions general rules, where you don't have to have the same fraction denominators, that you just go ahead and multiply across. And the thing with division is it's a lot similar to multiplication. All you have to do is flip the second denominator, the second fraction, do the reciprocal and just multiply by the first, and just make sure that a and d in each case does not equal 0. That means that make sure the denominator does not equal to 0, because that would make the fraction undefined. Looking at the problem sets, we have number 1. What I would recommend doing first is just multiplying the denominators. 3 and 7. 3 and 7 give you 21 over 5 and 6 being multiplied together, which gives you 30. Now, as you can see, this fraction can be reduced. Just think as 21 being the product of 3 times 7, and 30 being the multiplication product of 3 and 10. You think of these 3's canceling out, leaving you with the fraction 7 over 10. Another approach to do when solving this problem, 3 over 5 times 7 over 6, so you can actually think of crossing out, cross multiplication, through going to itself one time, and through going to 6 two times. So if you just multiply across, you have 1 times 7 over 5 times 2, which is 10. Still yields the same answer, but this approach is a bit quicker and you don't have to worry with reducing at the end. Letter B, you have negative 2 over 3 times negative 4 over 9. So if we think about our rules of multiplication, we have negative times a negative. That's going to yield a positive answer. Okay, and you can go ahead and use our rules to multiply across, or you can use cross multiplication. And for this you will not be able to, because 2 will not go into 9 and 4 will not go into 3. You cannot do the 3 and 9 going to each other because they're across from each other. They have to be at opposite ends. So we multiply across, we have negative 2 times negative 4, this gives you a positive 8, over 3 times 9, which is 27. And that is the fraction of those being multiplied together. Now if we look at C, we have some mixed numbers in the pile. The best thing to do is to think about these two being added together and these two being added together. So you have to think of this in two separate mindsets. So we have 7 over 8 plus, and remember, any one can be written as a fraction of itself over itself. So we want 8 to be the denominator to keep these the same. So we have 8 over 8, which reduces to 1. And now if we try to add these together, leaving the denominators the same, we have 8 plus 7, that is 15. Now over here we have the fraction of 1 over 4. And we have to turn 2 into a fraction where 4 is the denominator. And to do that, you have to say the denominator you want, which is 4, multiply the number that you already have, which is 2. So 4 times 2 is 8. And if you look, 8 divided by 4 would reduce to 2. So carry down our multiplication symbol. We have our fraction of 4 over 4. Now we just add our numerators. 8 plus 1 is 9. Okay, as you can see, nothing will cancel out, so we have to just multiply across. And when you do that, you get 15 times 9, which is 135, over 8 times 4, which is 32. And if you were to reduce this fraction further, you would get a mixed number of 4 with the fraction 7 over 32. Now if we look at dividing, the rules say that we'll keep the first fraction the same, but now we'll multiply by the reciprocal, or the flipped fraction. When we do that, we'll take 3/4 and flip it to have 4 over 3. And then just do our simple multiplication of 5 times 4 is 20 on top, and on bottom we have 7 times 3, which is 21. Okay, with B, we'll keep that first fraction the same of 7 over 8 times the reduced, or the reciprocal of 5 over 4, or negative 4 over 5. Remember that negative just traveled on top. Okay, now we can use rules of cross multiplication. 8 will go into, or 4 will go into 8 2 times. Make sure to leave that negative there with that. And 4 will go into 8. Oops. Excuse me. Negative 4 will go into itself 1 time. Make sure to leave that negative with it. And negative 4 will go into 8 2 times. So if we reduce, we have 7 times negative 1, or negative 7, with 2 times 5 on the bottom, or 10. Okay, now we're going to look at adding and subtracting fractions. If you notice, we have C's on bottom, meaning that we have to have common denominators, and make sure C is not equal to 0, because that would make the answer undefined for each adding and subtracting. Also pay attention to the fundamental law of rational expressions. If A, B, and C are integers with B not equaling 0 and C not equaling 0, then A over B can be thought of as A over B times 1, written as a fraction of something over something. Now if we jump into problem set 6 and look at some examples, we should be able to use those rules we just learned and apply them. Okay, so if we look, 3 over 7 plus 4 over 7, we have common denominators, so we'll keep that denominator, but we'll just add what's on top. We have 3 plus 4 is 7. So it turns out we have the fraction 7 over 7, which reduces to just 1. Looking at 2, we have 3 over 9 plus 10 over 9. We have common denominators, so we don't have to worry about getting common denominators. So we'll leave the 9 on bottom, just adding the 2 on top. 3 plus 10 is 13. So 13 over 9 is our answer. Okay, looking at 3, I believe it's the last with the common denominators for adding. Since they both share the 7, let's keep the 7 on the bottom. Now worry about what's on top. 1 plus 4 is 7. 1 plus 4 is 5, excuse me. So the answer is 5 over 7. Okay, now we start looking at some problems that do not share common denominators. So when we do that, we want to go with something that both will go into. And if you look at number 4, we have 3 over 7 plus 13 over 14. If you look between the two, 7 and 14 will both go into 14. So what I'd like to do is just leave the 13 over 14 as it is. Now to make the 7 become a 14, we have to multiply by 2. And what we do on the bottom, we have to also do in the top. And if you look, we're just multiplying by 1, which is written as a fraction 2 over 2. And we do that, on bottom we have 2 times 3 is 6 on top, and on bottom we have 2 times 4, which is 14. So we have 6 plus 13, which is, excuse me just a minute, which is 19 over 14. And finally, for problem set 6, number 5 has 54 and 90 as the denominators, having the problem of 1 over 54 plus 1 over 90. So what we need to do is make something that both will go into. 54 will not go into 90, and 90 will not go into 54. So what we need to do is we can say that both 54 and 90 will go into some number, and then for this case we're going to use 270, because if you look, 54 and 90 will both go into 270. So how do we make this 1 over 54 have the fraction of 270? We're going to have to multiply by 1 using the fraction 5 over 5. And we multiply 5 over 5 times 1 over 5, we get 5 over 270. Let's carry our plus down. And now we have to think about what numbers can we, or what one form can we multiply 1 over 90 by to get 270? And the answer is you want to multiply by the fraction 3 over 3, which does reduce to 1. So 1 times 3 on top is 3, and on the bottom we're going to have 270. Now to combine these two, you just go ahead and simply add. So you have 5 plus 3 on top, which is 8, over 270. And if you were to reduce, this fraction could reduce down to 4 over 135. Now for problem set 7, excuse me. It starts off by having common denominators of 10 over 54 minus 1 over 54. If you just carry these out, 10 minus 1 on top is 9. Leave 54 as the denominator for both. And finally, for number 2, what you want to do is get common denominators. You have to think of a number that both 15 and 6 will go into. So if you do that, 15 and 6 both go into 30. Just use some multiplication and do some tinkering around, and you realize that both will go into 30. So if we do that, what number do we have to multiply, and what one form do we multiply 15 here to get it to 30? Well, if you think about it, we have to multiply 2 over 2. So you think about that, 2 times 13 is 26 over 2 times 15, which is 30. Carry down our plus. Now we think about 5 over 6. What number do we have to multiply by 6 to get 30? Well, that would be 5. So I have to multiply 5 over 5, which will reduce to 1. And excuse me, that should be a minus. So if we were to multiply across, 5 times 5 is 25 over our 30 fraction. Now simply, 26 minus 25, we have 1 over 30.